For this example, we need to graph relations and connect the points. After we're done with that, we're going to graph the inverse and identify the domain and range of both the original relation as well as the inverse. A relation is a set of ordered pairs, and you can see in this table we have 4 different ordered pairs organized in this XY table. So I'm going to go through to start with, and I'm going to graph these 4 points. So the first point is the point 0, 2. And then we have the point 1, 5. The point 5, 6. And the point 8, 9. We are going to connect each one of those points that we just graphed with a straight line. So our graph of this relation looks like this. In order to determine the inverse, we need to take each one of those x and y coordinates and switch them around. So the first point in the relation, the original relation, is the point 0, 2. If we take that ordered pair and switch those around, that would be the point 2, 0. The original point 1, 5, if we switch around, that would be the point 5, 1. 5, 6 would become the point 6, 5. And the point 8, 9 would become the point 9, 8. And we're going to take those 4 points and connect them also with a straight line. So the original relation, the original table, is done in blue, and the inverse is the one in red. We want to identify the domain and the range of both the original and the inverse. The domain of the original, domain are our x values. So if you look at the graph, how far to the left and to the right this graph goes, that will give us the domain. Our x-axis goes left and right, so the domain basically tells us how far right and left our graph goes. The point that's furthest over to the left has an x-coordinate of 0, and the one furthest to the right has an x-coordinate of 8. So our graph goes from an x-coordinate of 0 to an x-coordinate of 8. All of the points in between are filled in. So that means that our domain is from 0 to 8 inclusive. Our textbook will put this into set builder notation. If you remember how that works, we start with this wavy bracket. The domain are our x values, so we'll put an x there and then a vertical line. And then from there, we want to make a statement about our domain. So again, our domain values, our x values, go from the smallest being 0 over to an x-coordinate of 8. So I want an inequality to represent that information. So the domain for the original function is from 0 to 8, including 0 and 8. We want to do the same thing for the range. The range values are y values. So in set builder notation, we would have the wavy bracket, our variable y, the vertical line, and then our y-axis, that tells us how far up and down we're going. So we want to take a look at the graph and determine where the lowest point is and what the height of that point is, all the way up to the highest. The lowest point on the original relation has a y-coordinate or a height of 2, and it goes all the way up to this point here, which has a height of 9. So our range are all of the y values from 2, including 2, up to 9, including 9. So the blue graph, that is the graph of our original relation, and here is the domain and the range of that relation. We're also supposed to determine the domain and range of the inverse, which is graphed in red. The domain and range of the inverse is always easy to determine once you have established what the domain and range of the relation is. The domain of this inverse function, well, how we determined the inverse function, how we went through and graphed these is we took each one of the x and the y coordinates and we switched them around. The x became the y and the y coordinate became the x. So the point 0,2 in the original became the point 2,0 on the inverse. Basically what that means then, since the domain are our x values and the range are our y values, to determine the domain and the range of the inverse, we can just switch these around. The domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. So, the domain of our inverse, those are the x values in the inverse. Those were the y values in the original relation. So you can take the range from the original and copy that down for the domain. You do have to switch the variable to x, but the values will remain the same. So the range in the original were all the values of y from 2 to 9, including 2 and 9. That will become our range. And the range of our inverse, those y values were the x values in the original. So for the problems that have directions that look like this, go through and graph the original table. Take the x and the y coordinates of each point, switch those around to graph the inverse. Establish the domain and the range of the original. And then the domain of the original becomes the range of the inverse. And the range of the original becomes the domain of the inverse.